Hi, in this we are going to see about microdiversity and macrodiversity. Diversity. It is a powerful communication technique that provides wireless link improvements at relatively low cost. Diversity exploits the random nature of radio propagation by finding independent signal path for communication. These independent paths are highly uncorrelated. The need of diversity is if one radio path undergoes a deep fade, another independent path may have a strong signal. Two criteria are necessary to obtain a high degree of improvement from a diversity system. The first one is the fading in individual branches should have low cross correlation or highly uncorrelated. Second, the mean power available from each branch should be almost equal. The classification of diversity. Macrodiversity. It provides a method to mitigate the effects of shadowing as in case of large scale fading. Second one is microdiversity. It provides a method to mitigate the effects of multipath fading in case of small scale fading. Macrodiversity. Large scale fading is caused by shadowing due to the presence of fixed obstacles in the radio path. Long-term fading can be mitigated by macroscopic diversity. Microdiversity. Small-scale fades are characterized by deep and rapid amplitude fluctuations, which occur as the mobile moves over a distance of just a few wavelengths. These fades are caused by multiple reflection from surroundings in the mitigated by the diversity using multipath antennas on the base station or mobile unit. Activity. Diversity techniques. Space diversity. The space diversity is using antenna spaced through enough at transmitter or receiver side. Polarization diversity. Using antennas with different polarizations. Frequency diversity. Using frequency channels separated in frequency more than the channel coherence bandwidth. Time diversity. Using time slots separated in time more than the channel coherence time. Space diversity. It uses more than one antenna to receive the signal as shown in this figure. The generalized block diagram for space diversity is shown. Selection diversity, feedback diversity, maximal ratio combining, equal gain diversity are some of the space diversity types. Selection diversity. Selection diversity is simple and cheap. Receiver selects branch with highest instantaneous SNR. New selection made at a time that is the reciprocal of the fading rate. This will cause the system to stay with the current signal until it is likely the signal has faded. A block diagram of this method is similar to space diversity. M demodulators are used to provide M diversity branches whose gains are adjusted to provide the same average SNR for each branch. The receiver branch having the highest instantaneous SNR is connected to the demodulator. Scanning diversity. It scans each antenna until a signal is found that is above predetermined threshold. If signal drops below the threshold value, it rescans again. Only one receiver is required, so less cost and still need multiple antennas. Maximum ratio combiner diversity. In this, signal amplitudes are weighted according to each SNR and summed in phase. The maximum ratio diversity is most complex of all types. A complicated mechanism, but modern DSP makes this more practical. Equal gain diversity. It combines multiple signals into one. It gives better performance than selection diversity. The signal from each branch are co-phased. Polarization diversity, which is which uses antennas of different polarization. The antennas takes advantages of the multipath propagation characteristics to receive separate uncorrelated signals. The SNR is improved by up to 12 dB even in line of sight channels. The theoretical model of polarization diversity is given in this figure. A polarization diversity antenna is composed of two antenna elements V1 and V2, in which it makes a plus or minus alpha angle with the y-axis. A mobile station is located in the direction of offset angle beta from the main beam direction of the diversity antenna. Frequency diversity. It is implemented by transmitting same information on more than one carrier frequency. Our aim is to make these carrier frequencies uncorrelated to each other so that they will not experience the same phase. To make them least correlated, these carrier frequencies are separated by more than the coherence bandwidth of the channel. Theoretically, if the channel are uncorrelated, then the probability of simultaneous fading will be the product of the individual fading probabilities. Frequency diversity is often employed in microwave line of sight links. These links uses frequency division multiple mode. In practice, 1:n production switching is used as shown below in frequency diversity technique. The production switching is provided by a radio license. In this case, one frequency is nominally idle but is available on a standard by basis to provide frequency diversity switching for any one of the other n carrier. When diversity is needed, the appropriate traffic is simply switched and backup frequency. The assessment questions. Thank you.